All right, 2.1, here's a review of quadratic functions and models. So let's take our typical quadratic equation. F of x is going to be equal to ax squared plus bx plus c. And we know this is a parabola. And if a is positive, we know it's going to open up. And if a is negative, we know that it's going to open down. We also know that if it opens up, at the vertex, this is the vertex, and the x-coordinate of the vertex is going to be at x equals a minus b over 2a. Likewise, if it opens down, we still have a vertex, and the coordinate, the x-coordinate here is still going to be x equals minus b over 2a. Now, another thing we know, let's take, so this is also called a minimum point, and this vertex is called a maximum. Okay, let's look at our typical equation. Y is equal to ax squared, and this is for when a is equal to 1, we just have our parent function. But if a is greater than 1, we have what we call a vertical stretch. And so it's going to look something like this. This would be for a is greater than 1. And we call it a vertical stretch because the function or the line is stretched away from the x-axis. Now, if we had a was less than 1, in other words, a fraction, the curve would look more like this. So this is a is less than 1, and this is called a vertical shrink because the graph shrinks towards the x-axis. Okay, now let's look at the standard form of a quadratic equation. Instead of y equals ax squared plus bx plus c, the standard form, or as I like to call it, the vertex form of a quadratic, f of x is equal to a times x minus h squared plus k, and the vertex is at coordinates h, k. So that's why I call it the vertex form. So let's do an example. Let's say f of x is equal to x squared minus 10x plus 24. So this is not the standard form or the vertex form. So what we want to do is we want to identify the vertex, and we want to find the axis of symmetry, and then we want to sketch it. Okay, so a problem like this, the first thing you want to do is put it into the vertex form. So how do we do that? Well, we just complete the square. And by completing the square, that puts it into vertex form. So notice in this equation, the a, if I put an a here, the a is 1. So I'm just going to say f of x is equal to 1. I don't have to do that, but you'll see it's a lot easier when you're completing the square if a, the coefficient of x squared, is 1. But we're going to do another example on x where the coefficient is not 1, and you have to factor that out. So anyway, let's carry it on. So f of x is going to be 1 times x squared minus 10x. Then I'm going to put a plus and then leave a space and close the parenthesis. And then what comes next is the plus 24. And now I go in and fill in the blanks. So how do we do that? Well, you look at the value of b, so b is a negative 10. You take half of that, negative 10 divided by 2 is negative 5, and you square 5, negative 5, so it's going to be plus 25. This is always going to be a plus here because you're squaring it. And so if you're adding 25 to the inside of the parentheses, you have to subtract 25 outside of the parentheses. And now what we have here is a perfect square trinomial. So this is factors to be x minus 5 quantity squared. And then we have a plus 24 minus 25, so that's just a minus 1. So here's our standard form. F of x is equal to quantity x minus 5 squared minus 1. So we can look at that, and we know what the vertex is. So we can write that next. Vertex, we're just going to put 5 and negative 1. Because remember, it's h minus, or x minus h. So h is 5, k is minus 1. This is h, and this is k. Okay, so now we identified the vertex. The axis of symmetry is at the x value. So the axis of symmetry, we'll abbreviate it AOS, at is x equals 5. That's the middle of the parabola. And now we're going to sketch it. So just draw a coordinate frame. Oops, put it this way. And first plot the 5, negative 1. 2, 3, 4, 5. So here's your vertex right there. And we know it's going to open up because the value of a is positive. And so when you sketch it, then all you need to do is do something like this. It doesn't have to be really pretty. If I say graph it, then you want to plot points. Sketching it just gives you an idea of what the graph looks like. One more thing before we move on. So we found the axis of symmetry at x equals 5. We could also find it just using the original equation, because axis of symmetry is at x equals a minus b over 2a. So if we look at our original problem, minus b is a minus 10. So minus a minus 10 is going to be 10 over 2a. A is 1. So 10 over 2, which is 5. So we can find the axis of symmetry just by looking at the original equation. We don't have to have the vertex form. Okay, example 2. F of x is equal to 2x squared minus x plus 1. And we still have this, plus 1 minus 1/8. So that would be 8/8, completing the square. Notice that our value of a is not 1, so we're going to have to factor out a 2 to begin with. So we're going to go f of x is equal to 2. Now when we factor 2 out of the x squared, we just have x squared. Minus, when we factor a 2 out of the minus x, we have a minus x over 2. Then we put a plus, space, close the parentheses, and then we have to add 1 because of this here. So now, if we were to stop right here and just multiply the 2 times the x squared, we get the original 2x squared. If we multiply 2 times a negative x over 2, we just get a negative x. So we haven't changed anything. Now we're going to look at, this is b. b is 1/2. And so we want to take half of that and square it. So half of b is going to be 1/4. And we're going to square 1/4. That's going to be 1/16. Now, we added a 16th to this equation, but we really added the 2 times the 1/16. So this 2 times this 1/16 gives us 2/16 or 1/8. So we really added 1/8. So we have to subtract 1/8 on the outside. Okay, so let's come down and clean this up a little bit. So we have 2. Now, what we have here is a perfect square trinomial. So it's going to be x minus always, always takes that sign for right here. And half of b, which is going to be 1/2 of 1/2 is going to be 1/4. So it's x minus 1/4 quantity squared. Now we still have this, plus 1 minus 1/8. So that would be 8/8 minus 1/8 is plus 7/8. Now you notice I did all this without decimals. And so you should do these without decimals, if at all possible. And most of the time it is. So here's our f of x is equal to 2 times x minus 1/4 square, quantity squared, plus 7/8. So now we have to identify our vertex, which is easy now. Vertex coordinates are, so this is 1/4 is h, this 7/8 is k. So it's 1/4, comma, 7/8. And we know our axis of symmetry is at the x coordinate of the vertex. So this is x equals 1/4. And now we want to sketch it. So let's get a coordinate system here. Our vertex is 1/4 and 7/8. So let's call this 1, 2. So 1, 2. So 1/4 and 7/8 is going to be, I guess, right around there. We know it's going to open up because the a is greater than 1. And so when we sketch this, all we have to do is just kind of take it up and do something like that. Now notice it doesn't have any x-intercepts. No x-intercept, because the vertex is above the x-axis and it's opening up. Okay, our next example 3, f of x equals negative x squared minus 4x plus 21. And we want to find the vertex. We want to find x-intercepts, if there are any, and we want to sketch it. So notice that we have a negative x squared. So I'm first going to factor a negative 1 out of it. So f of x is equal to negative times x squared. Then it's going to be plus 4x minus 21. So factoring a negative out of this. And so now I can complete the square. So it's going to be a negative of x squared plus 4x plus space, parenthesis, and we have a negative 21 out here. So now we're going to complete the square. We're looking at half of 4 is 2. 2 squared is 4. And so we're adding, but it's going to be negative. Remember the negative out front. So we're subtracting 4 on the inside, so we have to add 4 to the outside. I should have made this, should have been a plus 21 because I'm factoring a negative out. Okay, I set this up wrong. This plus 21 should have been outside of the parentheses, so I'm just going to move it, make it a plus 21 here. So this is a plus 21. Okay, so now we're squared away. So we have a f of x equal to a negative, then we have a inside the parentheses, x squared plus 4x plus 4. We had our original plus 21 outside, and then we're actually, this is a negative 4 on the inside, so we have to add 4 on the outside. All right, so now this is a negative. This perfect square trinomial becomes x plus 2, quantity squared. Then we have plus 21 plus 4 is plus 25. So vertex is going to be a negative 2, 25. And so now we want to find the x-intercepts. Well, the x-intercepts is at f of x equals 0. And so we plug in 0 for our f of x. And so 0 equals a negative x squared minus 4x plus 21. That's our original equation. Now I'm going to divide everything by negative 1. 0 divided by negative 1 is 0. So this is going to be x squared plus 4x minus 21. And so easiest way to do this, factor it. So this is a x. So the sign is negative. The last sign is this one right here is negative. So one has to be plus, one has to be negative. And the factors of 21, that'll get us to a 4, is a 7 and 3. And since the sign of 4 is positive, that goes with the bigger number. So we have 7 and 3. So this is equal to 0. So that means our x-intercepts at x equals negative 7 and 3. So another way to write it is negative 7, 0, and 3, 0. So now we're ready to sketch this thing. So let's get a coordinate frame. And let's see. Yeah, I don't want to put it there. Let me put it closer to the middle. And let's put it here. So negative 7, 0, 2, 3, 4, 5, 6. There's one intercept, and 3 zeros, another intercept. And our vertex, where was our vertex? Negative 2, 25. Okay, we can draw, usually draw your axis of symmetry with a dashed line. Now I didn't leave enough room to graph this thing, but it's going to go way up to 25 and then back down, something like that. So this would be the vertex. It's not quite to scale, but it's going to be negative 2, 25 is the vertex right there. Okay, so that's it for the first day on 2.1, and we'll continue tomorrow.